R3 and R4. And those two currents are going to combine. And then they're going to join in with R2. So we can't really go any farther until we get that branch. So we're going to come back. We're going to take off our other current node that was coming through here, coming down, and that current there came in, and it divided up across R5 and R6. So that's this one right here. So then the other one should have been, so it went in and then divided up again. So it went through R5, and then R6. Those two currents came in and those two currents combined, and then those two currents went into R2. So then it's going to go up. And then R2 then is going to come in and it's going to join together with R3 and 4. So we can just go ahead and join those all together. Now I got all my total current back, and it's going to go through a switch and then R1. Then I'm going to have my switch. And then R1. And then back up into my source. Okay? So just try your current pass. Force yourself to split. Anytime you come into a current node, create yourself a current divider. And get those things so you can see what's going on with your circuit there. So then here's R1. Then we know that we have 24 volts. We'll write down all the information I have. So R1 is 10 ohms. R7 is 4.7 ohms. R3 is 80. R4 is 270 ohms. Okay, so we got all our resistance in there. Gotta get our test points in there, so we're gonna have test point A. Between the switch and R1 is going to be test point B. Test point C is going to be between the switch and R2. D is going to be between R2 and R5 and 6, so it's going to be D. We got C, D, and then E is going to be between R7, the positive side of R7, and the negative side of R3 and 4, so that's going to be right here. So here's test point E. And then F is going to be our ground. That's going to be right here. Okay? All right, so any questions on that part? So that's what your circuit should look like. Then we want to make sure we have our current paths and polarities on it. So we know that all my current is going to be coming out of my power supply, and it's going to come in, and it's going to come up into my first current node. Some of my current is going to come up this way. Some of my current is going to come into this one. So this current is going to go all through R7, and then it's going to come into another current node, and that's going to split. And some of it's going to go through R3, and some of it's going to go through R4. And then those two currents are going to split. This current here, in our second branch, is going to come into another current node, and that's going to come up. And that's going to go across R5 and R6. And all that current is going to go through R2. And that current is going to join in with the first branch through the switch. And all my current is going to go through R1 and back into my source. think we have all the information we need. Alright, so there's that. So there's what your equivalent circuit should look like. So now what we need to do is we need to reduce it down to a series circuit. And we're going to just use the voltage divider formula. So all we need to do is just get it down to one series circuit. So what would be my first step? Which ones can I combine first?
R5?
Yeah, I can combine R5 and 6, because those two are in parallel, and at the same time, I can also combine R3 and 4 together at the same time. So I'm going to have all my current coming down, it's going to come up and it's going to split. Some of it's going to go through R7, some of it's going to go through the combination of R5 and 6. So I know that I got still have a current node, so I'm going to go force myself to split. R7 hasn't changed, but I can go ahead and I can combine R3 and 4 together. So I'm going to make up an equivalent resistor there. So this is R3 and R4. This is R7. This other one that I went over off to this way, this one in and that one, I'm going to make the combination of R5 and 6 into one resistor. So that one's going to come off. I'm going to make R5 and 6 here. Make that down to one resistor. Then that one's going to go up through R2. And then those two are going to combine back together again. So then I can just kind of join those back together again. I can go up. I'm going to go into my switch. Into R1. Back into my source. So R1 is still going to stay at 10 ohms. What's the combination of R3 and 4 going to be?
108 ohms.
108 ohms?
Yeah.
Okay, 108 ohms. What's the combination of 5 and 6 going to be?
88 ohms.
88 ohms. Okay, R2 didn't change, that's still 12 ohms. R7 is going to be 4.7 ohms. Alright, now we got our current path and polarity, so all my current's going to come through. It's going to split. Some's going to go through R7, some's going to go through R3 and 4. Split, come back through. Join together, go through my switch. Go through R1 and then back into my source. Then I got 24 volts. Then I want to get my test points in there, so I still have test point A. This is going to be B. What's this test point going to be? Right here.
C.
That one's going to be C. Okay, and then this test point here between R2 and 5 and 6. D. The one between R3, 4 and R7, E. And then our ground, which is going to be our test point F. Alright, so now we have, there's 10 equivalent circuit. So now what would be my next step? Now what can I combine?
R2 through R7.
Wait, I got to be careful about that because R2 and R7, this I got a parallel branch here, right? But I got two resistors that are also in series first.
So you can do R7 with R5 and 6.
Right, I can do these two first because these are both in series. So I can combine these two, and I also can combine these two at the same time. So I'm going to redraw my equivalent circuit. force myself to go back up again. So I know that all my current is still going to come down and it's going to split. I'm going to make myself a branch. Then this one here, I'm going to combine R3, 4, and 7 now. This one here, I'm going to combine R2, 5, and 6. And then now those two are going to combine back together. Go up to my switch. Back down. Okay, so now we have R1 is still 10 ohms. So the combination of R3, 4, and 7, what's the total going to be on that one now? 112.7 ohms. Okay, and then how about R2, 5, and 6? 100 ohms. Okay, so everyone agree with all that stuff so far? Okay. At 24 volts again. Oh, my current paths and polarities. All right. So there's that one. Now we can redo it one more time. So now which one's going to combine? Right. So now you can combine those two, and those are going to be in parallel. Switch. So what's my combination of R3, 4, 7, 2, 5, and 6 going to be now? 52.98 ohms. Okay, everyone agree with that then? So it's going to be R2 through R7. It's going to be a combination of those. Let's make sure we get our test points in here. So here's test point A. Test point B. Test point C here. Now you can see once we combine these two, we lost test point E and we lost test point E. They're no longer in there because they're mixed in within this parallel circuit now. So we lost that, and the only thing we have left in is F. All right, got 24 volts. We got all my current coming down, this guy coming up. My switch, and back. All right, so I'm going to do it. I'm going to show you a different way that we do it when we're out in the field. Is that we don't calculate out currents. We're going to do everything with our voltage divider formula. So right now, all I have to do then, if I'm going to do the voltage divider formula, is I just have to get it down to a series circuit. So once I get it down into my series circuit, then I can divide up my voltage across R1 and R2 through 7. So what's my voltage going to be using the voltage divider formula? What am I going to get for a voltage across R1? All right, what'd you get?
Wait, no, it's voltage divided by okay.
Well, you got to figure out your total resistance, so I'm going to take that. So what do I get for a voltage across R1? The voltage divider formula.
3.810 volts.
3.810?
Yes.
Okay. And then what's my voltage across R2 through 7 then?
20.19 volts.
21.19 volts?
20.19.
20.19 volts. Okay? So then we'll put in our test points here. So we got test point A,
C. Ground, and that's gonna be F.
Okay, so what am I going to measure for voltage for test point A then? What's going to be my voltage at test point A?
24 volts.
Yeah, positive 24 volts. Okay, and then how about at test point B?
0.810.
What do I get for voltage at test point B? Assuming the switch is closed.
20.19.
Yeah, positive. Positive 21.19 volts. Okay, and then at test point C?
Positive 29.
Yeah, positive 20.19 volts. And then F is going to be your plus or minus 0 volts. Okay? So we have all the information we need on that. We don't need to know anything about current or anything like that. We just needed to know that. Then we can transfer all our information that we know. We know that this is going to be a positive 24 volts. Test point B is going to be positive 20.19 volts. Test point C is going to be 20.19 volts. C or F is going to be plus or minus 0 volts. All right, then our voltage across R1, we can write that down. We have 2.810 volts. So now what's my voltage across R3, 4, and 7?
20.19.
Yeah, our 20.19 volts, because what remains constant in parallel circuit? Voltage. So we just take our voltage from here and go into a parallel circuit, so we can just transfer that voltage across both of those. So we know that's 20.19 volts. Okay? So now we have all our test points, we have all our voltage drops on this one. I don't think we have anything left on that one to do. So now we're going to take our information that we have on this one and bring it over to this one. So now we're breaking out R3, 4, and 7, and 2, 5, and 6. So now looking at R3, 4, and 7, I'm going from this one resistor to what type of a circuit now? Series. And what, and so what's another name for a series circuit? Voltage divider. So I can use another voltage divider formula to divide up my voltage across these two. And what voltage am I going to use for my source voltage?
20.19.
21.19 volts. That's my source going into that parallel circuit. So I can take the total resistance of this branch resistor, of this branch, get that total resistance, and divide up my voltage across those two resistors. So what am I going to get for voltage going across R3 and 4?
volts.
19.34 volts. Okay, then how about across R7?
841.8 millivolts.
841 point what?
8 millivolts.
8 millivolts. Okay, and if I add those two up, I should equal what?
20.19.
20.19 volts. Okay? Then I got the voltage for those. Everybody agree with those? Okay? Then I can do the same thing with R2 and 5 and 6. Divide up that, take that 20.19 volts and divide those up using the voltage divider and get the voltage for that. Come up with your voltages, let me know what you get for voltage of R2 and R5 and 6. Wait, hold on, Mike. Hold on. Wait, say again?
Oh, 2.4, 2.3,